All right, we're going to look at problem number 9 on the back of the review sheet. And remember, this problem is a combination of series and parallel. So first, let me just draw the picture. And again, you're not being graded on artistry or anything like that. So we have 120 volts, and this is 30 ohms. What you need to do is you need to get in the habit of labeling your resistors. So in this case, I have 3, so I'm going to call this one R1. I'm going to call this one R2. And I'm going to call this one R3. Okay. Now this problem is easier in that they give us like the voltage, the total voltage. When you think about this problem, the first thing I want to do is I want to keep simplifying and get intermediate schematic diagrams. And the way that I do this is I have to look at the current. So I know the total current is coming out of the battery. The total current goes through this resistor. When I get to this point, the current's going to divide. Okay? So the first thing I'm going to do is I'm going to draw a new intermediate schematic. So I still have R1 is 30. And in place of R2 and 3, I'm now going to have a new resistor that I'm going to call R23. So the first thing I'm going to do is going to calculate that. So to do that, what's the relationship between these two? Because this current is dividing, I know that they are in parallel. So 1 over R23 is equal to 1 over R2 plus 1 over R3. So 1 over 50 plus 1 over 450. So now I'll find a common denominator. So 9 over 450 plus 1 over 450 is 10 over 450. And luckily, this is one I can do in my head. Okay? So I'll just get rid of those zeros. So 1 over R23 is equal to 1 over 45. So I cross multiply. So R23 is equal to 45. So that means over here, this is 45 ohms. Now they didn't ask me for what it's R23, and what I'm going to do in this problem is I'm just going to solve for everything. I'm going to solve for more than what they asked for, just to show you how in circuits you have a foolproof way as you're doing this to go back and check your work. Does that make sense? Okay. All right. So now I'm going to look over here. And I have 2 resistors that are in series. How do I know they're in series? The same current that's flowing through this resistor is flowing through this. It's like water flowing through a pipe. I'm always going to look at the current to find out what is the relationship between the resistors. Does that make sense? Okay. So R1 and R2 are in series. So when I redraw this again, instead of R2 and 3, I'm going to have one resistor I'm going to call R1, 2, 3, which is really the total. How do I find that? Because these two are in series, I'm going to say RT is R1, 2, 3, which is R1 plus R2, 3. So it's 30 ohms plus 45 ohms. So RT is equal to 75 ohms. So that was one thing I needed to do. So again, as you're doing it, you might want to say, oh, these are in series. All right. Whenever I get to this point, I know I have my V, which is 120 volts. And then coming out of here, I have my IT. So remember, I can apply Ohm's law to part of the circuit, or I can do it to the whole circuit. So I'm going to use Ohm's law here for the whole circuit. I'm going to say V is equal to IR. So I'm going to say IT is equal to VT over RT. So it's 120 volts over 75 ohms. So this comes out to be 1.6 amps. Now remember, in series, I'm going to start, now I go back and I use my intermediate schematic diagrams. And in my intermediate schematic diagrams, I always say to myself, what's the same? So I knew that these two resistors were in series. So what's the same in series? In series, I know what's the same is the current. I know that in series, IT is equal to I1 is equal to I2. So what does that mean? Well, because I added those two in series to get this, and because this is 1.6 amps, now I'm going to go back here and I'm going to say I23 is 1.6 amps, and I'm going to say I1 is 1.6 amps. So what I'm doing is, because I knew these two in series were in series, and I know in series the current is the same, I'm going back and using my intermediate schematic diagram to get these two currents. Okay, so now I'm going to say to myself again, if I look here, do you see that I have two things here? Do you see I have two things? Right? So what are the two things that I have here? I have R and I have I. So if I have R and I have I, what can I find? V. So now I'm going to say that V1 is I1 times R1. So 1.6 amps times 30 ohms is 48 volts. And then I'm going to say that V23, remember that's R23, is going to be I23 times R23. So that's going to be 1.6 amps times 45 ohms is equal to 72 volts. So in physics and in doing circuits, I have a foolproof way to check my work every time. So what I'm going to do now is, before I go on, I'm going to say, you know, I think I want to check my work. And I know that these two resistors in series, the voltages add up. So as a quick check, what I can just do in my head, okay, I don't have to do this on paper, I know that the total voltage would be V1 plus V23. So that would be V1, which I just found was 48, plus V23, which was 72. So this comes out to be 120. Is this 120 equal to this? It is. So now I see I did a mistake. So I don't have to do this. I just do a quick check in my head to make sure, am I doing all this correctly? All right. So now I have, so basically I think I found everything in this. I don't know if I need to go back. So now here I have R2 and 3. Does everyone see that? So R2 and 3, how did I get R2 and 3? Where did R2, 3 come from? R2, 3 came from adding R2 and R3 in what? Parallel. So now I'm going to say, okay, when I did that with R2 and R3, that was parallel. So I'm going to say to myself, what's the same in parallel? Okay. So what's the same in parallel is the voltage. I know that VT is equal to V1 is equal to V2 is equal to V3. So now I'm going to go back. These two are in parallel. So that means that V3 here is equal to, whatever this voltage was, which was 72. So that means this is 72, and this is equal to 72. When I wrote here VT is equal to V1 plus V2, that's when it's just parallel. All right, that's not V1 here. So now here, look at this. So now for resistor 2 and resistor 3, okay, if I have V and R, what can I find? I can find I. So you see how I'm using Ohm's law again? So now I'm going to say I2 is equal to V2 over R2, which is 72 over 50, which comes out to be 1.44. And then I'm going to say that I3 is equal to V3 over R3, which is 72 over 450, which comes out to be 0.16. Now remember, in circuits, you have a foolproof way to check your work. So to check again, these two, remember, in parallel, the current adds. So I know coming down here, the current is 1.6, and it divides between these two branches. So the current here and here should equal about 1.6, right? So here I have a foolproof way to check my work. Now, of course, in this problem, I didn't ask on the sheet for you to solve for all these things. I'm just showing you how you can go back and check your work every single time. So you can go back and say, so the thing you're always going to do is you're going to look at the resistors and you're going to say what's in series, and you're going to say what's in parallel, and then you're going to go back and check. Okay?